In this unit, you'll be learning about motions and 2D kinematics. The learning target for this unit is I can describe the motion of an object by its position, speed, or velocity, and acceleration using words, algebra, graphs, and numbers. We can start out by asking what is motions, and often when we describe motion, we refer to an object change in its positions over a certain period of time with respect to from fixed point. And we also describe motion of everyday language using the words such as fast or slow, whether objects moving or not. But using the adjective in describing motions is not very clear because for example, I'm sitting in my room right now. So when you ask me, am I moving? One can say that, I'm not moving at all. And the other person can actually, I'm moving quite fast. The reason for that is, with respect to the ground, I'm not moving. Ground on my floor of my room, I'm not moving. But when you compare that my um, positions with respect to the sun, then I'm moving quite fast. Okay. So how can we make things a little bit more clear? We can make things more clear by have some terminology that we will use in physics that are clearly defined. And one of the terminology is distance. Distance defines the amount of ground object has covered. And distance is a scalar quantity. And we learned from our previous unit that a scalar is pretty much something that just have a magnitude. It's just a numeric value, for example, 60 miles per hour. That is a scalar quantity. Displacement is a change in position measuring from the starting position to the final position. And displacement is a vector because it describes both the magnitude and direction. Look at the figure to the left here, you'll see that the difference between distance and displacement. Imagine you have a monkey and that monkey take 5 steps north and then 5 steps south. When you ask what's the distance that the monkey travel, you can say that the monkey travel a total of 10 steps. But when you ask what is the displacement of the monkey, then you can answer that the monkey has a displacement of 0. Okay. What is speed? Average speed, as we define it, is the distance traveled over a certain period of time. And the unit for speed is mile per hour, kilometer per hour. And average speed is a scalar because it doesn't have direction. Velocity, however, is a change in position over time, or pretty much displacement divided by time. And so, because displacement is a vector, you see up here, it makes average velocity and it makes velocity a vector quantity. You can say, well, 50 miles per hour west, 50 miles per hour east. I can use kilometers, but also you have to have direction with that. So in the case in which a monkey take 5 steps forward and 5 steps backward, a total of 10 seconds, what that means is the speed of the monkey is 1 step per second. Okay, because 5 steps forward, 5 steps back in 10 seconds, which means 1 step per second. But the velocity of the monkey is pretty much 0 because its displacement doesn't change. It's starting from 0 and in where it is, so 0 divided by time, so making the velocity of the monkey is 0. If I run on the circle track 60 miles per hour, then what is constant speed or velocity? Of course, some of you probably ask, that's not possible. How can you run 60 miles per hour? Well, if you think about a future where I'm half robot, and that is possible, okay? So imagine some distant future, some half robot, I can run 60 miles per hour around the circle track right here. I'm asking you, what is constant? Is it the speed or velocity? Pause the video a little bit and see if you can figure that out. All right, that's enough time. The thing that is constant is the speed. Why? Because the velocity It's a combination of both speed and direction. As you know here, the speed might be 60 miles per hour, but the direction constantly changing. So therefore, the velocity is not constant because directions keep changing. So this is a question for you, kind of quick review. And again, I want you to pause the video to think through this. How is velocity different from speed? Okay, just pause and think and talk to your neighbor and see if you can describe what you just have learned. Let's look at this two table right here, table A and table B. Which table has the constant speed? And if the speed is constant, then what is the numeric value of its speed? Okay, I want you to take a few seconds to figure that out. Pause the video, and when you're ready, just click play again. So we look at this two table. You know, there's table A, the times from 0 to 4 seconds, and table B also from 0 to 4 seconds. But table A, it seems like the positions is changing from 0, 6 meter, 12, so 18, 24. So go up by 6 every single time. So this right here, the speed is the constant. But you look over here, 0, 1, 4, 9, 16, which means the distance is keep increasing, not in a constant manner, but seem like more like exponential. So A is the answer. Okay, table A, speed is constant, and the numerical value for that is 6 meter per second, because every second is increased by 6. All right. Let's move on to the next one. This is numeric understanding. Look at the number and get information out of it. Okay, let's look at this one. Let me move myself up here. All right. So this one, describe the motion of the police car if it drips oil every second for the scenario A, B, and C. So if you have a police car here that travel from left to right, and every second the police car kind of drip oil on the road. Okay, and your job is to describe the motion for this three case here. So pause the video, see if you can describe it in terms of maybe speed, where they're speeding up or slowing down. Okay, so in scenario A here, you notice that every seconds the distance that is pretty much the same, so you can say that it have a constant speed here. Okay, in this case, you know that the distance increasing for every second, meaning is speeding up, and then the distance remain constant again. So it speed up to a certain speed, and then it just remain at that speed throughout. And right here, you see that it start out and then it keep increasing. So the speed keep increasing. Okay. So for this diagram, I want you to graph using the position first time graph. Okay. To pause the video, I want you to use all the data that I've given you here and create a graph position first time graph. Okay. Click pause. So the position first timeline should look something like this, where you have positions in the vertical axis with a unit of meters, and you have time in the horizontal axis with a unit seconds. Okay. From this, what you can tell is that the object is moving right. We define positive is we just define usually positive number is to the right and negative number is to the left. So that's why you can see this number is going up here. Actually, I make a mistake here. There's no change in velocity for this one. Sorry, let me move back here. The spot velocity is I make a mistake here. The velocity is constant. Okay, because you can see every second that it just increased by 10 meters, and so therefore the speed is constant. That way it covers the same distance every second. Okay, so I make a mistake here. This should be constant velocity. Okay. I want you to try this one. Graph, again, the position versus time graph. Just pause the video, graph, and see if you can do it. What information can you get from your graph? Your graph should look something like this. Positions in vertical axis, time in the x-axis, and notice how it's increased kind of exponentially. What we can conclude is that velocity is, if you look at the slope of this line, the slope will keep increasing. And the slope of this line will tell you the velocity. And so there's a change in velocity for this graph. So for this one, the object's moving right, which is positive, and it's changing velocity. Okay, so this one is correct. So let's combine everything that we have learned. We learn how to describe motion using words, and also we have algebraic equations that describe speed and average speed and average velocity, and we have numeric value in a table that allows you to understand the motion object. So now we're going to combine everything to have a deeper understanding of motion here. As you can see here, you have a car moving to the right. Okay, it moves at a constant speed, constant velocity. And the slope of this line is, slope in math is delta y over delta x, a change in y divided by change in x. That's pretty much rise over run. Rise is position and run is time. So in a sense, the slope of this position time graph will tell the average velocity. Okay, so remember that. Okay. Again, the slope of a position versus time graph will tell you average velocity. Okay, so that's pretty much it. Next time, we will be talking about accelerations. Thank you.